Chicago for hosting, and SHI-BIPSA is the International Building Performance Simulation Association. That was hard. So they do energy performance modeling and all that. So thank you for hosting this online in a webinar format. As Mark mentioned, we're here today not only to educate the folks of Chicago on retrofitting an existing residence into Passive House, but this is a test bed for the conference in December, so thanks for letting us impart this on you guys as well. And if you have any comments, feedback, anything, we'd love to hear it, so don't be shy. So I mentioned it on the introduction, but I work with Database Plus, which is a research component of dbHMS, which is an engineering design firm. My background is in architecture and early phase analysis. I had gotten into Passive House specifically for this project, actually, and it's been a wonderful process.
And I'm April Hughes. I introduced myself earlier. What you need to know about me is that I didn't just fall into Passive House by accident. I worked on a number of lead projects over my career, 4 platinum projects, and I had never done a Passive House. So I can talk about how we got there, but this is my first Passive House. So I thought I'd do something that was super difficult. Okay, here we go. So I'm not going to parrot these back to you, but let's just say we're going to talk about some very specific constraints that this project encountered from design forward, including, before that, our pro forma. We're going to talk about some code issues, particularly related to HVAC for this project. And I'll speak up. And then we're going to talk about some VRF, which is that HVAC situation. And we're going to talk about how this project needs to have some sort of replicable components in order to really move the needle when it comes to retrofitting Passive House. So here's the background. Also funded a project for a group called Harmony House for Cats. It was a cageless, no-kill cat shelter, which was incredibly fun to design, but it was also a lead platinum project that also aimed to be operationally net zero. It also had a large solar component, about 96 solar panels. Solar is really important to this client, and demonstration projects were really important to this client. So fast forward from 2006 to 2012 to 2017, and Michael Yanell's home, let's see, does this thing do that?
Yeah.
I don't want to turn it off.
I don't know where.
Okay. This is Michael's home, right there. And the home right here was under 2 different situations going to be developed into an upzoned lot, which would have infringed on his solar rights. Something like a 45-foot tall structure. One of them was townhomes. So Michael banded together with his neighbors, got in touch with the alderman, demanded a shading study be done. Ultimately, the project backed out of the lot, and Michael purchased it. And then he called me. So that makes your pro forma a little difficult. Not only is this project in Ravenswood, where some of the homes are larger, the lots are larger, the price points are higher, and I know this is antithetical to the small home movement, okay, but I'm working with what I had. So as you can see, if you're going to do something that's not only existing but also speculative in that market, you're dealing with some crazy numbers here, okay? And obviously I'm being very transparent. The decisions that were made here percolated through the rest of the project. So if you guys know anything about homes at all, you're going to pay 6% to a realtor. You also, if you're going to develop a project, you want to make a profit, ideally. Here we're showing that our client is not making any profit. We're also showing that we tested this out in a bunch of different configurations. This is 4 of those configurations. Essentially, the concept was, could we do this and sell it just simply renovating the home as is? Could we do this, renovate it, add an addition? Could we do it Phius? Could we just do it light green? Would we have the money necessary, and after the purchase of the lot, would we have enough left to do the renovation and actually be able to sell it? And so what we came up with was, we couldn't be at the lower price point, and this is why. We did a substantial comparables analysis on this project with Dreamtown Realty Swake Group, and what 25 properties showed in the immediate area surrounding the property over the past 12 months, and this was done in 2018, was that we had to hit a situation where we were having at least 4 bedrooms. And if we were going to make it to the next price point up, we actually had to have 4 bedrooms on the second floor. So if this project was going to move forward and be a demonstration that Phius could be done on an existing building, and we weren't going to rip this thing down, and we basically had to say to ourselves, are we going to take a big hit on this, or are we going to actually try to develop this so we can closely cover the nut and sell it for either a small loss or no loss at all? So what this resulted in is a design that has a true 4th bedroom on the 2nd floor. We finished the basement because in many of these homes that are being sold at this price point, there's an area for a child care professional or a grandparent that's living with the family, so there has to be an ensuite. And what we also found, of course, is what we knew, which is when you're trying to get comps on a home that's a Tesla, you can't compare it to a bunch of Corollas, and that's what we have. So how do you price a Tesla in a Corolla market? Well, you just saw what we tried to do there. So now I'm going to dive into some of the challenges, and then I'm going to end up passing it over to Scott to get a little bit more specific about the MEP challenges that we had. So one of the challenges that we had was this is an existing property. It's 120 years old, and the zoning that's laid over the top of it made it existing non-conforming. So if you also want to add exterior insulation to the outside of that, you're screwed. So we thought we could get away with an administrative relief, is what we were told. Essentially, what we ended up having to do was apply for a variance, which of course had to have the support of the neighbors, an extra 30 days. We did it because we already knew we had the support of the neighbors, but there are recommendations that I think we're going to make at the end of this that could essentially make some of these things a lot easier for retrofitting existing buildings in tight urban areas. Just to give you a little bit of a visual here on what we were dealing with, this is what it looked like. It had been vacant for 10 years. It had significant lead and asbestos that needed to be abated. That also played into the cost. Also another reason somebody might tear it down, but also have to abate it anyway. And ultimately, the upstairs had so much animal-related things in it that it also had to have a special environmental consultant come in and clean it out. So nothing could be easy on this project. So when we started to peel off the successive layers of our envelope, all of our cladding, that was what was keeping the building upright. So we lost a lot of lateral stability and had to stabilize our project almost immediately. And another thing that you should probably just safely assume about a project like this, and due to its age, is that it's balloon framed, which is kind of a good thing. So now I'm going to pass it off to Scott.
Yeah, and just to give everyone the big picture idea of what the performance criteria was for this project, here's a quick diagram of that. I'll just jump through it quickly to orient everyone. So the above grade exterior wall ended up being approximately R48 for the assembly. Below grade, as we transitioned underground, it was about an R24. Under the slab, R20. The roof, we did R100. The windows from Sierra Pacific. The installed U value came in at 0.1875, and our solar heating coefficient was about 0.5. We ended up going with a Zender ERV with the credited efficiency of 0.83 and humidity recovery of 0.4. The efficiencies we got out of the VRF for cooling SEER was 23 non-ducted, 18.5 ducted. Heating COP, 4.6 non-ducted and about 4 ducted. We utilized a hybrid heat pump water heater, COP of 3.1. And to get down to the pre-2018 energy criteria, we needed to install a 2.72 kilowatt array.
So I'm going to spend a little bit of time on this a little bit later in the presentation, but this is to basically show you our foundation and how we were adding our insulation. So one of the things I'm going to dive a little bit into further along is where we placed our air barrier in this situation. One of the things we ran up against in an existing home of this age was it turns out it didn't have a footing. So we had to figure out where we were going to place our drain tile, which made some things difficult. And the basement leaks like a sieve, right? And if you want to ameliorate that, then you need to figure out how to seal that up. Well, a lot of times you should come in from the outside, right? But that is so prohibitively expensive when you are trying to do something speculatively. So we decided to abandon that and that cost and add the insulation to the inside. And then above grade, you can see that, I feel like I'm gonna get stoned here. So the size of the home, makes me an asshole. The other thing that makes me terrible is this spray foam insulation, right? So why did we go there? Well, we didn't originally go there. We were trying to do a batt or a mineral wool. But after we started doing some successive modeling, Wolfie modeling, and then ultimately it will show through the blower door test pre-drywall, we weren't gonna make it. So we ended up having to switch to the lowest global warming potential possible closed cell polyurethane spray foam in order to close this thing up.
Take it over. So here's a few iterations of the Wolfie modeling we did. On the top is where we finally landed with incorporating the dynamic shading from our neighbors. As April mentioned in the beginning, we have a friendly neighbor to the south that is unfortunately blocking all of our southern gain that we'd want to take into account. Well, you can't.
Urbanity.
Yeah. So that was one of the reasons that we were pushed into the spray foam category. We needed more R value in the wall, and we couldn't get there without utilizing spray foam. So just to show you in the second iteration where we would have been if we went with mineral wool cavity insulation instead, we were coming past the heating load threshold. And obviously we can't do that. So, and then finally on the third and bottommost section, I just wanted to show that if the southern neighbor was removed and we could take advantage of some of the solar, free passive solar, we could have done mineral wool in the cavity wall, and we could have cut down on the thickness of the exterior insulation a little bit, saving cost essentially across the board, and not having the spray foam essentially every inch of the envelope.
Is this 2015 or 2018 metrics?
This is 2018 metrics.
Okay.
Thanks for asking.
Sorry,
So we, when this was in for design review, it was around the time in which we could adopt the 2018 pilot program. So we elected to do so because it gave us a little more flexibility on the cooling and heating demand of a home of this size with that much surface area. So that ultimately worked to our benefit as well. And I'm thankful we were able to do that. So here's another issue that we had to get across. So this house is in the city of Chicago. The city of Chicago has its own mechanical code, and that code is pretty antiquated. What it requires in bathroom and kitchens is either to have an operable window that complies with your 4% openness to floor area ratio, or to provide exhaust at a rate of 1.5 CFM per square foot. So take our bathroom in the basement scenario. It's a 60 square foot bathroom. Oop, our arrows moved a little bit. 60 square feet times 1.5 CFM per square foot, that's 90 CFM. I'm sure there's some passive house projects out there that their total CFM is probably less than that or close to 100. So this one bathroom is making us really reconsider the way in which we had to design our ventilation strategy. Down on the bottom is what Phius recommends, 24 CFM, so we're already working at a difference of 66 CFM just because of this bathroom. This is a diagram of our approach to the HVAC. we're utilizing the strategy that most passive homes use with the ERV, being collecting exhaust at your bathrooms and general kitchen, running through your ERV to utilize heat recovery, and then supplies being put into all the occupiable spaces, including bedrooms, kitchen, rec areas, et cetera, living rooms. On the right-hand side, you have a snippet of what the VRF system eventually became, and on the next slide, I'll show you where it started. But we ended up with 2 condensing units that feed a series of terminal units throughout the house. If anyone came to the presentation last month, that was focused on mechanical systems and single zone mini splits and multi-zone mini splits and ducted units. So this is a good segue into the application of that. So we ended up with a number of zones on one condensing unit and then a number of additional zones on a second unit, and we'll get into why that happened. So on the left-hand side, we have our original approach to how we're going to do VRF. And dbHMS has strong experience in commercial and multifamily design. So we approach this from that standpoint. What would a commercial VRF with heat recovery look like? And I'll reiterate what heat recovery does. It was mentioned last month, but essentially what's happening is you can have someone in the basement heating while someone on the second floor upstairs is cooling. So you're heating and cooling at the same time. There's one refrigerant loop that's running through the entire house, and you're either pulling from it or rejecting from it based on what the demand is in that space. And because you can pull or reject, you're able to take additional efficiencies from that condensing loop. So it's a really efficient way to heat and cool your home or large building. So that was really damn expensive, at the tune of $90,000. So where this transitioned to was splitting up this format from one condensing unit to 2 condensing units. So on the left-hand side, we have one condensing unit serving the basement and the first floor. And then on the right-hand side, you have a second condensing unit serving the master bedroom and then the additional secondary bedrooms, all paired together. And the reason this happened was, again, due to cost and where we wanted to be with the HVAC system. And just to say, the $60,000 price point includes your Zender unit, all your ducting, all the terminal units, everything associated to HVAC. So sounds like a lot, but that's what this type of house demanded. So I'll run you quickly through the floor plans and where these units ended up going, just to orient you, and if anyone's curious about VRF, how this ended up working. So in the basement, we have a vertical fan coil unit that is ducting to the bedroom on the right-hand side and then pushing directly into the rec room on the left-hand side. And remember, this is on one of the condensing units. On the same condensing unit on the main floor, we have the high wall terminal units that you're pretty familiar seeing, similar to the mini splits, in all the occupiable spaces, living room, dining and kitchen, and then the family room. And then finally, on the top level, we have a ceiling cassette that's ducted to the master and some support spaces there adjacent, and then a vertical fan coil unit that is serving all the additional bedrooms. To go back to what we originally wanted to do, we wanted to have a high wall, mini split-esque terminal unit in each of these spaces. We felt that thermal comfort and the ability to control these systems was of the utmost importance. You have a lot of spaces. This isn't your typical passive house. It's 4,000 square feet. It's 3 levels. It's selling at $1.5 million. We wanted people to have the highest level of controllability and the highest level of thermal comfort possible.
Okay, so here's a little bit of good news. That makes me feel good anyway. So we're working with the builder, and this isn't actually part of the slide, but I'm just gonna drop it in here. So we're not working with a passive house builder on this. I think that's a really compelling part of this project. We're actually working with a builder that's doing 100, 200 homes, Chicago and the suburbs every single year. When new home building is at like an ultimate low, like from like the end of World War II is what we're dealing with. So custom home renovations for them at our level are coming in between $200 and $230 a square foot. That's really in the middle of gut rehabs because you can do them at 100 or you can do them at 400. Our contractor, MK Construction, is also a developer, and their new builds are coming in anywhere between $140 to $180 a square foot. That's in the city. That's basically all the same features except for the green features or the passive house features. So our project is coming in at about $192 a square foot. To me, this says you can do this. And more importantly, if you're talking about replicability, it's not just wanting to do it or needing to do it or having the money to do it, but it's also having the knowledge to do it and the training to do it. And if we can't figure out how to do this with a bunch of these homes that are exactly like this on the north or south side of Chicago, we're not going to be in very good shape no matter how many new buildings we build. So I think this is an important demonstration, and sometimes that's where it needs to start. It's not perfect, but I think that it's a compelling story. So here's some fun stuff that we've been dealing with. When you are doing a passive house and it exists and it leaks like a sieve, you decide that you're going to do a bunch of blower door tests before you throw up the drywall. So these are the results that we were getting. We did these all last month. We're putting up drywall right now. In fact, I think Carissa actually might be done with that. Our first blower door came in at 2,400 CFM. Fail, major fail. So,
And this is when we thought we had it sealed.
right. So this whole thing is chasing, right? We're chasing these things. So the first thing we chased was the basement. The basement is our problem. We had located some areas where insulation was improperly installed. We had specified a closed cell to come in, and they put in open cell. So that had to be replaced. Not in very many locations, but important locations. We also saw that the air barrier had been damaged, and so we needed to repair that. Okay, we're going to be fine. We're doing better. Do it a week later. 1,900 CFM. Okay, but little bites. So look back at the basement. Construction strategy issue. Where does the air barrier go? So I can go back to our wall section here. So we originally had the air barrier behind our studs on top of the insulation. That wasn't working for us.
Oh, there you go.
So we removed it from this location. We added spray foam insulation and we placed it on top of the studs. So then what happened? So then we got down to 1,600 CFM. Okay, how are we going to get there now? Well, this project needs to come in around 400 CFM.
Before the 500.
Right.
Yeah.
So we took a look at the foundation again. We pried off the top of the subfloor at the location between the existing building and the addition, and that's where it was at. So we insulated that location and we got down to 800-ish CFM. Again, going through identifying other areas of infiltration, and at the end of the day, for better or worse, on a home like this, spray foam has been our friend because that's how we're plugging these holes.
So here's just a few images of the progress of blower door testing. As April mentioned, we've been out there a number of times already. Ibrin, who introduced himself a little while ago. Just in the initial pass, you could walk around and feel air coming in a bunch of areas, probably where you'd assumed where we're framing windows, where existing is meeting new, and just all over the place. So we didn't even need to do smoke testing in the beginning. You could just feel this. And that was our first iteration. The second iteration we came through, we started to do smoke testing, identifying some of these areas. This is how we figured out open cell was used instead of closed cell. You could see the smoke just getting sucked right through there. We also had a lot of issues on the second level at the attic plane. How do you seal that? You essentially have to spray foam the entire perimeter of that attic space where it meets the wall. You have rafters in the roof coming in. A lot of areas just needed that extra oomph that we really rely on spray foam to deliver. Yep, in the city that are very passionate, not just Passive House US, but AIA 2030, AIA Coat, Illinois Green. So what could we do as a community to come together and start to lobby the city to help make projects like this easier to do so we have any hopes in the world of hitting our 2030 carbon neutral goals? So one thing that to me is pretty obvious and is the right step, or essentially a baby step to getting to a net zero code, would be to adopt a stretch code for energy. So if you have projects that are doing deep green energy-focused strategies, going above and beyond energy compliance by quite a bit, the city should be giving something back to those projects, whether it's lenience on setbacks. If we're talking about multifamily and commercial, you're getting more FAR bonus out of your project, really making it worth the while to invest in these deep green projects. And then number two, for me, most passionately, the city needs to adopt a modern mechanical code. The mechanical code is antiquated. You might tell me, well, this is in the works, and it is. Chicago recently adopted IBC officially. IMC is to follow, but I've heard not until 2021. Who knows? That's another about 2 years of us designing buildings in Chicago on a 1.5 CFM per square foot exhaust requirement.
So expedite the permitting process. There's a couple things here. So one, we know that the environment department was basically vacated by the head, and now they're looking for a new replacement. So what do we need to do? One, we need to first have them understand what Passive House is, and they need to revamp the permitting process and make Passive House part of the opportunity for expediting permits. And right now that essentially doesn't exist, and the green permit process, I can say sort of at this point, is a little bit of a joke because it's not expediting anything. And finally, we talked a little bit earlier about zoning, overlaying zoning on a bunch of existing buildings and then having them all be existing non-conforming is already a problem. But if you're going to add exterior insulation to an existing building and it's going to be part of the calculation of setback, it's a major hurdle. So in a tight urban environment. So as long as it meets fire resistant requirements, et cetera, this should be allowed in our code.
Yep. Yeah. So that's it. And we have
and this is some B-roll from
someone could hit the play
film we're going to be
button
producing
on
on
the
the project. Just so you guys can see a little bit of it. There's no music or anything fancy yet.
And we'll start taking questions while this is running in the background, hopefully. Oh, yeah, whatever.
Question.
Yes.
Question about the certified contractor. Knowing what you know now, would that have changed, or just the price point was just sort of?
I would love to download the history on this, but I'm going to be nice. So we did hire someone who was certified to do this, and we ended up parting ways. I think ideally now, I think we do have a compelling story that we're working with the market to do this. But I will tell you that the Passive House builders versus the market builders were coming in at a factor of 200% greater overhead general conditions and profit. And if that's going to be the way that it is, then we're never going to get there, because you can't do that with volume. So that's sort of.
I don't want to ask this question, but
you probably shouldn't.
MK has done one of these. Are they going to be at 200%?
It's a good question.
Are they going to add their numbers to the next one, or?
MK has done all the technologies in this home. They've just never done them all together. So that's one. Two, I think they do see that building sustainably or green or with a third-party benchmark does give them a little bit of an edge in the market, but they haven't realized it in a sense that they would roll it out through their portfolio, right? So that is a great question. I still don't know that they would do that. They're sort of a little bit of an anomaly, I feel like, as far as the types of projects that they take on and the quality that they deliver. They'll take on anything from 1,000 square feet to well, let me say, 1,000 square foot renovation in your kitchen or your bathroom to a $2 million custom home. And I would encourage you to learn more about them because I think if they do a good job on this and they've learned how to do it correctly, that even though they aren't a certified builder, and I don't know that they ever will be, they could handle a project like this.